So peptides are essentially very small proteins. So they are short chains of amino acids. These are the same sort of basic components, the same building blocks that proteins are made of. The only real distinction is that a peptide and a protein, one is big and one is small. So proteins are long chains of amino acids. Peptides are usually shorter, so we typically classify it as a peptide if it's fewer than about 50 amino acids. And because proteins are bigger, they typically fold into more complicated structures as well. Sort of peptides have become very exciting because they can inhibit protein-protein interactions that have been classed undruggable. So these undruggable protein-protein interactions, we can now begin to interrupt them using the power of peptides. If you find something that's really interesting, you then have to decide, is it a research tool, something that you can just use in the laboratory to ask particular questions, or could you potentially translate it into the clinic? And if you think about some of the very exciting work that's going on at the moment with weight loss drugs. So I'm thinking of semaglutide, which has been turned into drugs. Obviously, things like Ozempic and Wegovy, I think, is one of the other ones. That's very exciting, but there's a huge amount of investment and work that's gone into those molecules, those peptides being developed as drugs. So you have to go through various stages of clinical trials involving initially animals and then moving onward into human systems before it then can reach the market. So you're talking about millions and millions of dollars of investment going through a very carefully regulated series of steps before it can actually reach the market, and then it has to be approved by the drugs agencies. So, for example, the FDA in the US.